relevance. I would say so. And then my today discussion is going to be about the youth role for global development. In the very beginning, when Mr. Rahamim sent the invitation to me, it's a little bit confusing for me because actually I have no idea where I should put my affiliation because it is not because I'm the very important person, no, because I'm still looking for like what kind of place, what kind of position that suit for my for myself. I would say so. So that's why I said to Mr. Hamim that Impact Team 2050 is going to be like suit suitable enough for this very wonderful international conference. Maybe yeah, maybe we can share the screen, or Mr. Aditya, could you please help me to do that?
Yeah, I will share your presentation. Just wait a moment.
Okay, so sorry, I thought that I already unmute my microphone.
Oh yeah,
Not yet,
yeah.
right?
No, no, you already unmute your speaker before. So do you
Okay,
need
okay.
me to share your presentation?
Yes, please.
Okay.
Yeah,
Wait.
okay. I have no idea why my microphone always muted, but I will try to keep my eye on my microphone. So,
Yeah, I will
uh,
remind you. I will remind you
yes,
also. Yeah.
yes, please, please. Okay, so today discussion will be about the youth roles for global development, and then maybe we can go to the next screen. That based on my affiliation, my current affiliation, actually, from the Impact Team member for 2050 in a quite big company in Russia that we call Rosatom. And actually, today we should stay in Dubai in Abu Dhabi because of the not Abu Dhabi in Dubai because of the COP28, but because of some activities that I should follow in the Ministry of Agrarian Affairs and Spatial Planning for National Land Agency. So that's why I couldn't follow all the activities from the Impact Team member 2050. Well, so actually, what why like such young people should stay in this quite big company? So if you try to Google this kind of company that we call Rosatom, then might be you will see that this company is quite in how to say that, it's quite um impactful for the country itself, for the Russia itself, but also for other countries, especially from the African continent. So the thing is, we work worldwide with the young people who are active as young entrepreneurs, engineers, scientists, volunteers, and project managers. So after this slide, you will see like what we are, and then where we come from, and what we are doing for our field of study or field of occupancies. And then the second one is engaging girls into STEM. STEM stand for science, technology, environment, and mathematics professions to unleash their potential and support them through mentoring programs and training. Fresh ideas are welcomed. And then for the third one is building a diverse workforce at Rosatom that allows us to educate ourselves and grow together. So I will say that I'm quite happy here because I have a chance to be part of this company. Even though for this stage we are still volunteering all the activities that held by the Rosatom, but the thing is, it is not about like the settled job that we got from this company, but But the thing is, we can be heard, we can see, and we can be in a kind of situation or position that we can have our chance to speak, something like that. So we come from 12 different countries and 12 different backgrounds. We come from the first one you can see in the left side. Her name is Princey. Her name, she comes from the South African. And then my colleagues, like after Princey or Princess, we have Dongsu, and he's come from China. And then we have Nisanur uh, from the Turkey, and also we have Ignacio from the Argentina, and me myself from Indonesia, of course, and Laura that actually had very good opportunity to work in South Africa. So then she already left us, but I would say that her uh, her capacity in our team is still in there, something like that. And then we have Mujib from India, and also we have Iskandar from the Uzbekistan, and Diana from Kazakhstan, and also the last one, Gagik from Armenia. I joined this company since 2022, so actually it's not that long. And then I would say that I had a lot of opportunities to share my experience. And then not only that, but the most important thing that I can have from this company is actually like a lot of things that I can learn about. And then the thing is, I am like the third oldest member in here. So in this year, I'll be in my 31 years old. And then some of them from our member actually quite young, start from 19 if I'm not wrong. The thing is, I will say that my uh, my my in charge or my position in this company is quite late, or in a global uh, activities or global platform in nowadays in my age is quite late, because like maybe everyone can imagine when we can start our in charge in the international platform start from maybe 19 or 18, it's going to be like quite beneficial for like these young people, but also for like people behind them, something like that. So I believe that now we have a lot of students and also a lot of teachers or lecturers that I hope you all can like encourage yourself, or maybe like encourage our colleagues that still young enough to to involve with the international activities, because we can see like what happening in the outside, something like that. And then the thing is, why young people, why we really need to put young people in this discussion or in all uh, chance or opportunities that are actually quite important for everyone, because even though it's only like 16% of the earth population, but we have four goodness or I will say advantage for the young people, because they can speak louder. They have like louder voice to to share about everything they want to share, something like that. And then young people can master or can cope with the high technologies that some of like elderly or like I will say like senior citizen cannot do that. And also we have education. Some of us, I believe, from Universitas Muhammadiyah Surakarta as well, are easy to access the education. And then the last one is the accessibility to do everything. So those four parameters, or for those four indicators actually is the power of the young people that I believe like the senior citizen are not easy as young people can do. And then I got this data from the United Nations, and it said that the young people actually kind of have a range from 15 to 25. So I will say that even though I'm become the part of the young scientist group from the FAO and also like impact team member 2050 in this year, I mean in my 31 years old, but then I would say that maybe some of the young people from Indonesia still has no access to have this kind of platform. So that's why now I'm trying to encourage you all that I believe like the participants here are mostly from the students level to have kind of opportunities to find opportunities for the international platform, something like that. And then we also can say that in this slide, we see that the youth in Indonesia, based on the uh, population pyramid, we can see that actually not we are not alone. So there are a lot of young people in Indonesia that actually can work together, can spread the information about the international platform. So that's why we can be heard, we can speak louder, and then we can see and we can experience all the international activities or all the international events that are happening right now. Okay, so we can go to the next slide. Yep. And as what we have discussed earlier in the previous slide, that actually impact team 2050 current engagement um, is in the COP28 in the UAE. And then for me, it is quite interesting because everyone, I do believe everyone knows about the COP28 or the actually it's part of the UNFCCC that stand for the Conference of the Parties. And actually, this event is quite important for us, Indonesia, as part of the member of UNFCCC. Why? Because this event will become a platform for all the members of the UNFCCC, Triple C, to talk about the climate change issues. But if you notice, like the country that become the how to say that the country in charge, I would say, for this COP28 because it is in Dubai. And then you all know that Dubai from the UAE is the country that produce the highest fossil fuel in this planet. So actually that happening in all the member of the UNFCCC is like we are questioning why this COP28 happening in Dubai in the UAE because like it's quite ironic, it's quite contradictory when we are talking about the climate change. It means that we need to avoid the fossil fuel, but then why we held this COP28 in the Dubai or UAE is quite interesting for me myself, something like that. So that's why actually I'm quite sad because I cannot attend this event to see like what is the main reason why this COP28 happened in Dubai or in UAE. Um, let's go back to like our company Rosatom that bring us in the concept of impact team 2015. And then the main idea actually we go together, we work together, we research together about the energy transition. And it means comply to the nuclear power plant, or we can make it short as SANPP. The thing is, when we talk about the energy transition that we always campaign, I myself believe that this kind of issue or topic are quite related to the Sustainable Development Goals or 17 Sustainable Development Goals. And me myself are quite confident that the topic of the energy transition for the nuclear power plant or every type of the energy transition from the conventional energy uses are quite related to all the 17 sustainable development goals. For instance, let's talk about the climate change or the sustainable development goals number 13. We, I do believe that we all agree if we talk about energy transition for a better planet, it means that we are helping to reduce the climate change or at least to maintain the climate change, even though it cannot be it cannot be stopped. I believe in so. But then we can reduce the bad effect for that. So that's why we always talk about how to save the energy, how to educate people from, let's say, South Africa, not South Africa, but in the African continent or in other global South countries, something like that. Okay, let's go to the next slide because we only have 20 minutes for this presentation. So I'm not going to uh, talk more about like not necessary things, but I just want to bring you like in our activities, something like that. So um, I'm very happy to join this company, not because of like all the privilege that I got, that I can travel around, but then like the opportunities that I can get for funding itself. I do believe that everyone should agree with that. So I bring like my current team from ATR BPN or the Ministry of Agrarian Affairs and Spatial Planning or the National Agency because I'm working there actually now, become like the individual consultant or a senior advisor. And then I introduced this ministry to my company. And then we tell about like what we are doing here for for managing our land, for managing our spatial issues, and then they grew with that. So uh, I made sort of like a program. So between like this ministry to my company, Rosatom can work together. And I also bring one of the company that I also involved in, which is Mapit. I do believe that some of you also quite understand what Mapit is. So Mapit basically is kind of a startup company that work for the geospatial information. We model everything that related to the geospatial information. But in the next slide, we can see no, I mean like we can stay in the slide. I mean in the next slide, we can see like what kind of industry it is. And then I am Carto. We can go back to the previous slide, maybe. Yeah, I am Carto, or we can start it as a I'm Carto. Actually, is a startup company as well that is belongs to my colleague from Universitas Negeri Semarang, but now she's become the geospatial programmer in UK, London. And then we work together to solve the geospatial information issues in Indonesia, something like that. And then Transbulan actually is kind of the natural laboratory that run by one of quite well-known professor from Universitas Gadjah Mada. His name is Professor Junun Sarto Hadi, and now I'm working under his research center that Pak Aditya already mentioned that before. Its name is Research Center for Land Resources Management. And then the last one is the Young Scientist Group or YSG from the FIO that I also bring in this kind of project team management in the Impact Team 2050. We can go to the next slide, Mr. Aditya. Yep. So in this slide and in the next slide as well, I just want to show you like what kind of companies that I'm working in. So for the first thing, for the first company or institution, uh, I do believe that all of you already like knows this institution. It is Ministry of Agrarian Affairs and Spatial Planning, and we are trying to manage all the geospatial information in this ministry to have kind of the system that can manage digitally. Because so far, if we go to the national land agency in a provincial level or in a county or residential level, then people still need to go to the locale. But then, based on the RPJMN 2020 to 2024, that our president requests that all the ministry and institution need to digitalize, transform, or do the transformation of digitalization. So that's why me myself stay in this ministry to help this ministry to manage the the just platform information so we can access all the data digitally, something like that. Then go to the next slide. This is my bit that we already discussed before, and then this kind of startup company was born in Bandung Regency, and then I'm quite happy with this startup company because nowadays the community from this company is quite diverse. The community comes from the students from the university, good university in Indonesia, such as Universitas Indonesia and also Universitas Pendidikan Institut, mohon maaf, Universitas Pendidikan Bandung and some university in the West Java as well. And then you can explore the website itself that there are a lot of publication there, and then you also can access it, and you can also like subscribe this platform so you can model yourself for several data that available in this platform. You can go to the next slide. And this is the I'm Karto that I'm working with my colleague from Tes Negeri Semarang. The thing is, we are kind of a group of people that have the same enthusiasm for the just spatial information. So that's why we we kind of manage this platform. And then Nuris, like the co-founder, the founder of this platform, is quite eager with the geospatial information. Even she has the channel from the YouTube that has 100,000 of subscribers. So maybe some of you already knows her because she worked a lot with the like how to model some of geospatial analysis in ArcGIS or other platforms. And the next slide. And this is one of the most interesting that now I'm working in. It is a project that runs by Transbulan that I already discussed before. And the thing is, the idea of the Transbulan itself actually try to bring the community in a quite remote area, in an area that quite prone to the disaster, but they can survive. They can cope with all the situation there, even though like the disaster risk is quite high. So we call it as a productive conservation. So even though we need to produce like some agriculture products, but then we also do the conservation itself. As you can
Doc-
see in the
Dr. Eddie,
yes,
sorry, the time is 2 minutes more before
okay,
question
3 minutes.
and answer. Yes, yeah, 3 minutes is fine.
Yeah,
Before
okay.
question and answer. Yeah, please.
Okay, thank you so much, Mr. Aditya. And I'm so sorry because I talk too much, but because I'm so excited to share everything that I've worked with. Well, so in the picture below, you can see like all our efforts to help the community in a very prone to the disaster, like a drought and landslide in Magelang Regency. So actually, we don't really change a lot, like the life or the way of people live in this area, but then we adapt from it, and then we improve the way people live in this area. So we don't change because actually, as a scientist, I do believe that everyone here is scientist. Scientists is not that wise enough if they just change everything in a certain area and hoping that these changes will change the life of the people. No, it will ruin the life of the people in that area because they cannot just change dramatically everything they have so far. So that's why we are the one who should like adapt from what they are doing and then we improve a little bit. So in here actually uh we are monitoring like the physical situation in this area that prone to the drought and also landslide, so we can monitor it and we can reduce the element at risk in this area. And we already work with this area since 2013 until now, so it's already 10 years. And then we can go to the next slide. And I believe that this is the last slide that I can share to you, and you can read the rest slides that's still in there. But then I will stop in this slide because I'm quite proud with this team from the Young Scientist Group, from the FAO or Food Agriculture Organization, from the UN. And we proud because we already published our scientific report that everyone can access, and please cite this report for your thesis, maybe bachelor thesis or master thesis or doctoral thesis, because we work a lot for this scientific report. And again, thank you so much for this invitation. And don't stop to look for the chance to involve with the international platform. Thank you so much. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Very good
Well,
afternoon for everyone.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Edi Trijatmoko. What a nice and inspiring presentation. So we have a question and answer now. Please raise your hand and open your mic. Maybe one or two questions. Any question, please, to the audience? Yeah, there is a question in the text of Zoom. I will read for you, Dr. Eddie. So the question is Dimas Rizky Pangestu. This is I think it's a student from UMS. Yeah. Hello, introducing my name Dimas from UMS. What we know is that Rosatom is one of the world's leading company from Russia, which is engaged in the atomic field, especially nuclear power plant. Recently, Rosatom wants to build its nuclear reactor in Indonesia. The question are, first, can Indonesia resource make their own reactor? This is in line with Indonesian plan to reduce carbon emission. And what is the right location for the construction of the reactor? So, can Indonesia resource make their own reactor and which location? And the second one is, maybe your response about one of the countries that has a nuclear reactor, which dam is was into the sea, although they claim are safe and meet the requirement of the World Atomic Agency. I think Mas Dimas want to address the issue about the waste management of nuclear reactor in the second question. Dr. Eddie, please.
Okay, so actually it's a little bit complicated here because I need to put my luggage in the X-ray
All right.
sensor, but it's okay. It's okay. I can just get out from the
Okay.
X-ray sensor. so I can give like my proper answer. And
Okay.
I just see my colleague Mundi, but I believe that he's still staying in London, I guess. And I'm
Oh,
happy to see you, Mas Hendy. Well, so for the question of Mas Dimas, it is very good question, and it's still debatable because we all know that Indonesia is quite prone to the tectonic activities. So building a nuclear power plant or reactor in Indonesia is quite challenging for us and also for the company itself that want to help Indonesia to reduce the carbon emission that we promised in our NDC report or National Determinant Carbon report in 2045 that we will have the net zero carbon emission. So yes, I agree with that. And I do believe that if we start to like research for building the reactor itself, it's going to help to like uh, foster the um, carbon net emission in 2040. We need to work together to like kind of do the research where is the location that suit enough, that proper enough for building this reactor. But actually, when we are talking about energy transition or nuclear power plant, it's not always a reactor. It's not always the nuclear power plant itself. But then the company of Rosatom kind of have the CSR that also work with the research activities or education activities. So even though we're not having a chance to build our reactor, but then we can do something with kind of research or education that actually I really want to present for my last three presentation, but I have no time for it. But then, Mas Dimas, you can read yourself, and I hope that you also can give us kind of a, a scenario or project that we can propose to this company, something like that. Thank you so much.
okay, thank you. I think this is the last question. I don't want Mr. Dr. Eddie miss the plane because this event. So maybe I will contact Pak Hamim. I have also a lot of question about the collaboration, about the international community engagement with your company. But maybe later on, I will contact you by email or maybe by WhatsApp. Also, the audience, if you have any question to Dr. Edi Trihatmoko, please welcome to contact the chairman of ICDGM to get the email address of Edi Trihatmoko. I think Pak Edi will feel free to discuss and about the topic of geospatial and also the atomic nuclear reactor. Yeah, thank you very much, Dr. Eddie, for addressing interesting topics. We will send your certificate because I think you are want to check in and boarding the plane now. So again, thank you very much. On behalf of ICDGM, we will say thank you for your time and your sharing of your experience. And I will end the session with some closing remarks. So Yongs is very interesting. First, young people speak louder, and then young people master of technology, and then the young people often have high education, more high education, and also the last one is more important is young people often tasking. So please be the part of international platform, and we try to manage to find the access to our students to internationally by contact you later on. Thank you very much. I will come back to the Mbak Anti. Mbak Anti, I will give back the session. For me, wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you very much to Mr. Aditya and also Dr. Edi Trihatmoko for the presentation. And for the certificate, has it been given to Dr. Adi?
Yeah, I think we will send it to email because they are in the check-in check-in text today in this time. Or
Okay,
maybe
okay,
you can just show to the audience. It's just okay.
okay. And now the certificate handover session to our keynote speaker.
Yes, I will prepare first the certificate. So I will share. Here you go. Maybe you can give to Dr. Andy symbolic. Yeah. This is a
Okay.
certificate to Dr. Eddie. If you still monitor, please receive our certificate of ICDGM as a invited speaker, Dr. Eddie Tianmoko, as a part of the 2015 member State Atomic Energy Corporation of Russia. Thank you very much.
Okay,
Eddie.
thank you very much to Mr. Aditya and also Dr. Edi Trihatmoko. And the next is photo group session. Please to all participants to turn on the camera. Okay, we will have photo group session. Please turn on the camera. Okay, 1, 2, 3. Okay. Wait for a while. 1, 2, 3. Okay. 1, 2, 3. Okay, thank you very much. Okay, the next session, we will see presentation from invited speaker, Hendi Faturrahman, Master of Science. In this presentation, we will moderate it by Ms. Nirmalila Anggani, Master of Science. But before that, I will introduce our moderator. Name, Nirmalila Anggani. Educational background, Ms. Nirma was graduated from Environmental Geography Gajah Mada University and continue his master program on Population Study Department in Gajah University also. Her research are mainly focused about social and demography studies. Ms. Nirma now works as full lecturer at Faculty of Geography University of Muhammadiyah Surakarta. Now please welcome Ms. Nirma. Ms. Nirma, the time is yours.
Thank you, Mbak Anti. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, I start with this. First table, the chain of geography UMS, Mr. Jumadi, and the author of the geography UMS. Bapak Ibu yang terhormat, I'm sorry, I am Nirmalila. I'm lecturer of geography UMS. Now, I'm the moderator of the session seminar. I'm very pleased to see you here and welcome all of you to the seminar of ICGDM. Before we start the session, let me introduce our speaker. Our speaker in the session is Mr. Hendi Faturrahman. We destined to meet in forum. Of course, Mr. Hendi is my colleague's friend in the campus. I will read a CV of Mr. Hendi. The name, Hendi Faturrahman. Now, Mr. Hendi, lecturer of Fakultas Geografi UGM in the Department of Earth Technology. And now he moved to London and his family to school again, in the, wait, Mr. Handy now in the University of Cullen, right, Mr. Handy? Or I'm
University College London.
okay, University of
That's right.
College London in the Integrated Water Resources Management. Mr. Handy is a researcher. He interested in cars research group of Geography UGM. So many papers is published. One of this paper is pengelolaan ekosistem das di Kabupaten Gianyar, and then metode penilaian akurasi digital elevation model atau DEM untuk analisis geomorfologi di kepesisiran pulau kecil. And then Mr. Handy is still interested in U of A. Dipublish data pesawat udara tanpa awak untuk pendukung analisis dinamika pesisir dan erosi pantai, and simplified approach in karst aquifer characterization by using discharge variability, storage capacity, and void development. A primarily study in the tropical karst region and ATC. Mr. Handy, we give you in 20 minutes for presentation and 10 minutes for question and answer. Mr. Handy presented with title Reviving the Use of SCAD in Earth Science Studies. Now, the time is yours. Please, Mr. Handy.
Okay, thank you very much, Nirma. Can you hear me properly?
Yes.
Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. It's nice to see you here again, Nirma. And thank you for inviting me in this beautiful event. Well, let me share my screen. Is it up here already?
Yes, Mr. Already.
Okay. Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. First of all, thank you for having me here. It would be lovely actually to see you in person. However, I'm so happy to be involved and invited in this wonderful event. And my appreciation is also goes for the previous speaker, Dr. Edi Trihatmoko. Well, he's my friend as well in the university, just as Nirma. And okay, my name is Hendy. I'm a lecturer and also researcher at the Department of Earth Technology, Vocational College, Universitas Gadjah Mada. But currently, I'm pursuing my PhD degree at University College London. And today I'm going to share my presentation titled Reviving the Use of SCADs in Earth Science Studies. Okay, well, as it's described by Dirma, my background is in physical geography. We were in the same year of college, maybe 13 years ago, I think, or even more. And my research is mainly about disaster management, actually, so it's a little bit related to the topic of this conference. However, I also focus in the utilization of unmanned aerial vehicles or drone for disaster management studies. And I also often incorporate sketches and illustration in my research. So I hope it's relevant to the topic that I will deliver today, just to give you a context. So first, okay, I'm gonna start my presentation actually with the development of geospatial technology, geospatial software, and so on. I think now people tend to leave sketches or illustration from their research because they think it's too old-fashioned or it's too conventional. It's not so simple. It's very difficult to do for some people. But here, I will show you how we can take benefit from sketches in our fieldwork, in our research, or our analysis. So maybe after this presentation, you will have some insight and maybe you can change your mind that later on you can incorporate sketches in your research or field work actually. So the main purpose of my presentation is to encourage everybody, especially you are that working in the earth science studies, to try again to relook that we can actually incorporate or using sketch as something that is beneficial for our research. Okay, there are two sections of my presentation. The first is about field sketching. Here I'm not gonna teach you or give you a training, a workshop how to do the field sketch, but instead uh, I will highlight what is the benefit of field sketching, how can we incorporate them to improve our analysis, because you can just go online and also search for tutorial. There are so many resources out there that you can use. And second, it will be about illustration. Aside from the field work, there are also another type of sketch or illustration that you work on the desk with sort of some concept and so on. You can also use this to give a different impression of your research or something that you want to deliver to your audience or your reader related to your research. Okay, so first, Uh, on the left here, you can see some picture of me when I was sketching on the field. So sometimes during a field work or during a research, I spend about a half to 1 hour, more or less, to do a field sketch, whether it's in the middle of the field work on the during the break or after I finish the field work. But I always take my time to draw what I see, put annotation, put description, just to record what I saw on the field. And here you can see some of my collection. This is the collection of volcanoes. So this is some volcanoes from Indonesia or other places that I've been visited. And this is also some collection of beads and so on. But later I will tell you why should we take notes actually on the field or draw what we see. There are different ways that you can do for a field sketch. You can use it actually as an observation aid or to help you understand more about what you see on the field. You can use it as a field note. It could be a simple sketches without any color like this. You can put annotation about what you see, maybe rock structure, rock outcrop, or any landscape or landform that you see in front of you, and then you can put a little bit description about what you see. You can make notes or simple field book like this. Sorry, field sketch like this. But it could be also less academic. For instance, about the weather, you can write about the people that you met that day. You can write about the scenery that you see that day, about your mood and so on. So I do this the most. I use sketches as a daily journal, as a memoir, just like a diary. If maybe some of you write your diary. This is like very similar concept like that. So maybe some of you asking, why do we need to sketch? This is the main question. Why don't we just take a snap from a camera? Even now, I think all of your smartphone is already equipped with GPS. You can just take a picture, and if you are geographer, you can use the GPS camera. You can already put the geotag or the coordinates in your picture. It's easier to use. You can just snap and go, and you can even make a spatial analysis because it will be automatically geotag, so you can see the location. Or even if you want to get a broader view of your research area, you can fly your drone. You can get a very beautiful scenery with very broad view of your research area. So why do we need to draw? For some people, it's very difficult. Maybe some of you think that you cannot draw, and it takes time, of course, because you need to spend more hours on the field to do that. So why sketching is necessary? So I will bring some of the reason why it's necessary. But first, as I told you, maybe some of you think that you cannot draw. Actually, it doesn't require any artistic skills or interpretation to do a field sketch because uh, good or bad, we see it from different perspectives. But here we use the sketch uh, not as an art object, but we use it as an aid of observation. We use it to help observe what we see, to record what we see, and whenever we open our sketch again, it can help us to remember everything that we've seen on the field, and it will also improve our interpretation and also observation on the field. So first of all, I will like to emphasize this. So don't worry, everybody can draw. Uh, what people mean that they cannot draw is they can draw maybe as well as those they consider artistically gifted. However, this is not main point here because our main point to give an aid to our observation. And yeah, for example, if you go for a field or if you go to somewhere else to new place, and if you encounter very beautiful or stunning landscape, what will you do first? What comes to mind first? Yeah, I can assume that most of us will take a picture, whether it's for documentation, it's a collection, or even only for posting a story on Instagram. So maybe most of us will do the same, something like that. However, when you take a picture, there is a tendency just you take a picture and then go. Take a snap and go. There's a tendency to always do that. So again, when you open your gallery, when you already arrive at home, for example, if you are working on your data and so on, and you check your gallery, you will find so many pictures in your gallery, and even after that, you don't know for what purpose you took that picture, where you take the picture, in what occasion, for what purpose, and about the object that you capture. You didn't really have any idea of the picture that you take. But if you do a field sketch, you will sit for a while and then you will observe the object that you see in front of you. You will feel the atmosphere, you will feel the air, you will hear the nature sound and so on. And it will imprint into your brain that that memory will stay longer rather than you only take a picture using your camera. So one of the benefit of the field sketch is this is the aid of observation, and also you can also documenting what you see in front of you. Yeah, this is some picture of my sketch. The on the left you can see my sketch in my beginning career when I was a student, and this is my sketch from wait, I will put pointer. This is my sketch in 2018, I think. So of course you will improve when you practice, like yeah, when you practice it. I would say actually it's not something that only related to your skill, but you can do it by practice. And for me, sketching on location is powerful. You have to look at something really carefully to draw it. The process of drawing also will be stay longer in your memory, as I told you. And the main purpose of the sketch is again, this is the purpose of study rather than just way of illustration of art perspective. And then second, when you are using photograph, we have a problem with the illumination, with the lights, and so on. Sometimes it's quite difficult to interpret if the photograph that you take, the brightness is too much or it's too shady and so on. So it's better to use sketch to emphasize some objects that you see on the field. Uh, Here. And also, right now, many academics now working with aerial drones or aerial photographs to generate 3D models. But actually, using a drone picture, the problem is also similar with when we are using the camera. actually even you can generate 3D model, but it's not encourage you to do a careful observation on the field. Instead, it will require you more time to process the data after the field work when you are using drone. Uh, and using sketch actually something like this. This is a picture from a drone imagery. Uh, Here, actually, you almost cannot see anything, but using sketch, you can emphasize some feature that you want to see or you want to show it more prominent than the other object, for example. And right now, even the Indonesian Geospatial Agency or Badan Informasi Geospasial, they already incorporated sketches. I captured this from their Facebook page. So during the field work, normally they also do the field sketch to help them to interpret or do the analysis on the field, just to help them to observe. And also in some scientific journal paper, of course, they also use sketch and illustration or recording from the field work because sometimes it's very necessary. For example, this one, a paper from Voigt about the historical eruption of Merapi volcano. As you know, or just in case if you don't know, Merapi is one of the most active volcano in Indonesia, and with the very distinct characteristic of the lava dome building. So the lava dome is built up very quickly. So it takes a sequence of observation or data set or interpretation, sometimes using photograph, but the problem with photograph is not so clear. Again, if you want to see the development of the lava dome, for example, I think this picture will give you a clearer impression rather than a photograph. You can easily distinguish which one is the lava dome, and you can analyze also from the development like by month, for example, or even yearly using an interpretation using sketches. It's easier to emphasize the object you want to show more prominent. Uh, and this is from Wilhelm Junghun. Have you ever heard about Franz Wilhelm Junghun? So he was working with the Dutch Indies or VOC. Actually, is German botanist, geologist, and also geographer from our colonial periods. He traveled to Java and Sumatra, conducting research for East Indies or VOC. He was also well known as Humboldt of Java, extensive exploration of Indonesian island. During his expedition across Indonesia, he also documented his exploration using sketches and paintings. He published several books, such as this one, about art, and this is some of his collection in Java. So he drew Gunung Merapi, Gunung Gede, Gunung Sumbing, Dieng, Pantai Selatan Jawa, and so on. And this is one of his painting titled Suste Oswat for Rongkop, or The Southeast Ward of Rongkop. And in 2022, we made a documentary tracing one of his paintings. So this is the current condition of the area from Junghun. So he publishes this picture around 1851 or 1853, yeah, around that year. And then we try to track where this sketch taken, and then eventually we can find the place here. It's close to Mungap Pits in Gunung Kidul, eastern part of Gunung Kidul. And we compare his painting with existing condition, and we can see some change. For example, here we can see some morphological change. The cliff, some of the cliffs here are collapsed here, as you can see here. There's this cliff is not here anymore. The shape is changing, and here in his drawing there are big rock and also big trees here, and we cannot find it anymore. But we are not sure whether this is only his imaginary or it's actually was there. And also the telaga or the karst pond here is also not exist anymore. Maybe dried up, or yeah, or the reason he put this maybe only for illustrations, but we don't know. But I tried to make a new sketch again, very similar sketch, but of course not as good as his because I only spent like half an hour to do this, so it's not as good as his painting. But the thing is that it's very meaningful to me that I could trace someone else's sketch and maybe sit down at the same point, drawing the same objects, but 170 years apart, and it's just very interesting for me. So here I put the link for our documentary and also behind the scene. I will share my presentation later, and you can click on this link. Okay, and for me, sketch is also very meaningful as a memoir because it's a record of a place you've been visited. It can cherish it again or recall the memory whenever you open your sketch, your book sketch. Here is two of my sketches from the same place in Gunung Batu in Bali in 2018 and 2023. And then I still can remember like what day I made the sketch, with who accompanied me, what meal I ate at that time. Because of this sketch, actually, I remember almost everything, every moment when I was sketching, and it will be maybe always in my mind forever, I hope. And to close this first session, we use the sketch more academic diary, but it's also because you will stay longer to the observation and so on. And there's a proverb, a saying that a picture is worth 1,000 words. So I agree. I do agree with this. So maybe it it can encourage you to do the field sketch. Okay, the time is very limited, so let's carry on. This is the second part of my presentation. Apart from field sketch, there's also another type of sketch that is essential for earth scientist, for geographer, or other discipline. This type of illustration or diagram play a very important role whenever you want to depict something that you cannot do using photograph. Yeah, for example, like this. Now we can still see in the book, journal, or any other scientific publication that they still use or incorporate sketches or diagram like this just to give easy understanding to the reader or to the viewer. For example, here this is an example of drone image from Sangkulirang Mangkalihat Kars in East Borneo, and I want to put everything, every geomorphological feature to my audience, to my reader, but I cannot give it to them like separately like this. So I make a new sketch. I made a new sketch. I combine everything with the geological setting and so on. And even I put some annotation about the name of the landform. This is very typical landform of karst area in Sangkulirang Mangkalihat. For example, like this. And here, the second use of block diagram is to give you impression about the connection between the surface condition, geomorphological surface, and also the geological condition beneath the earth, beneath the soil. For example, here I made a sketch about Acropolis, the famous Acropolis in Athens. It has very typical, very unique geological condition. So of course, we cannot show them using photograph. We can only use illustration or model. So here I made a sketch of the Acropolis with the characteristic of the geological formation here, the limestone skis and so on. And another trick that we can do from sketches or illustration or diagram, if you want to show something that uh, you can combine many features into one illustration. For example, here this is the satellite image of uh, Yogyakarta province or special region of Yogyakarta. Uh, Even though the size of Yogyakarta is very small compared to any other provinces in Indonesia, but it has a very distinctive landform, very various landform. It has volcano, it has cars and coastal cars, it has the denotational hills, it has the sand dune, and also very typical black sand beach and so on. I want to show the the specialty of the special region of Jakarta from geomorphological perspective into one picture, but I cannot show them separately like this, or I cannot show them satellite image because you can just get satellite image easily everywhere. So instead, I make a sketch like this, combining all of the landform that exists in Yogyakarta into one sketch like this. So it has the volcano, it has the river, it has the karst landform, the old volcanic rock here in Langeran, Kulon Progo, Samigalo Hills, and so on.
I'm sorry, Mr.
This
Hendy,
is also
the time is
similar.
over.
Okay, maybe I will skip. This is just some example how I did my
Okay,
sketch, something like this. You
yes,
can
go
put
ahead.
annotation, and I will go to the conclusion. Maybe you can read it later on. So actually, the use of illustration is not only for scientific purpose, but you can also use it to make a book cover, for example, to make a calendar or any other purpose like very cool T-shirt and so on. And here, let's wrap up everything. I use sketch for an aid to observation, and I encourage all of you to also try to incorporate sketch in your research or field work. And because sketch can convey much more of the critical, morphological information than a photograph. The author is able to pick out the essential feature that relate to the objective of the field more clearly, rather than just take a photograph. And diagrams or illustration, this is a very interesting pictorial learning that you can use to communicate your research, your finding with with the audience or your readers. And then I put some references here that you can use. You can try to click some of the link for tutorial and also resources and so on. You can just email me here or just DM me on Instagram if you have any question related to my presentation or you have other presentation about the tutorial, how to do the field work. If you need that, I can send you by email. Okay, thank you very much, Nirma. And then that's all. Thank you for your attendance. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Hendy, for a great presentation. From your presentation, we, geographer, have a new insight, yeah, for any student. Yes. Any question for Bapak Ibu or mahasiswa? Okay. One question in the chat. Let me read. Let me introduce myself. My name is Huda from UMS. I have a question about artificial intelligence, Mr. Hendy. Now, we can make sketch easily. So, here's the question. Will you still make sketch manually in the future, considering that now there are so many human jobs that can replace by technology such as artificial intelligence? Please, Mr. Hendy, you can
Okay,
answer
thank
this
you.
question.
Thank you for the question. Very interesting question. Yeah, of course, now in this era, you cannot avoid to AI or artificial intelligence, even it's for geographer or any other discipline, like almost everyone, they are using AI. Or for some people, AI is very beneficial, but for some people, AI is very dangerous, right? Uh, yeah, and the question is, will I still do the first cut? Of course, yes, because yeah, the main point here is not about the result, not about the sketch result that you acquired, but it's more about the process. Because during a field work, as I told you, you will do the observation, you will sit on the field, you can draw by observing what you see in front of you, and the memory will stay in your brain longer. And this is something that you cannot get from the AI. From AI, you can just give instruction, blah blah blah, and then it will appear, the sketch will appear. And of course, using sketch, how to say, it's more like the personal satisfaction, like when you go to the field and then you have your sketch, you can have your own field notebook, you can show it to your colleague or your friend or your kids, for example. and you can keep it for the rest of your life, and you can reopen it again. But using AI, yeah, you can just make AI, post it on Instagram, and maybe 1 month later you will forget about it. So yeah, the main purpose here to do a first sketch is to make us understand more the area that we've been visited, the area that we research, uh, to have more memory about the observation. And the main point is to help us interpret more, because I told you before, when we are using a picture or AI generated picture or some other technology generated picture, it's very difficult to distinguish any prominent objects that you want to show. For example, if there's outcrop and very small feature that you want to draw, of course, you cannot just take a photograph from, for example, a crude scale that and the object cannot really appear in your picture. But instead, you can do field sketch that make this object that you want to make it more prominent, clearer. For example, you can put very light colors and mix shading and so on, as I show you in the previous presentation or slide. So the answer is yes, of course, I will still do this. Here in London, I still try to get, how to say, some location to do first sketch, because now it's winter here, so very cold outside. But I hope in the future I can have many collection of sketches from this area.
Okay. Any question? Pak Hendy, I'm curious. What if we don't have ability to sketch? How we start to sketch?
Yeah, as I told you before, actually, the main point is not about good or bad our sketch, because good or bad is always from different perspectives. There are some art that for some people they looks like a very bad, but it has very it's very valuable actually, like that. But of course, you can practice. I put on the link also the tutorial to do a field sketch. So actually, there are some key concept that you can do during a field sketch. For example, first, when you make a field sketch, you have to capture how to say, like, which area you want to sketch or which object, something like this. Sometimes we use for my presentation. I will show you. Wait a minute. I will share my presentation again. Just a moment. Is it up
Okay.
here? So I use this kind of frame. Actually, this is my professor, Professor Eko Haryono, if you know. And this is we went to the field, and then we try to perform the field sketch on the field. So we can use this type of frame just to capture which area that we want to sketch, and then we can try to sketch. And there are some key concept whenever we do the field sketch. For example, we draw the main horizon first, and then we draw the prominent feature first, and then we put shading. There are tutorial that I put on the link, so maybe you can follow that. But the point is that uh, you can try, and don't you ever think that you don't have the ability to sketch, because I think everybody can sketch. Even all of us, I think we already get the lecture as a geographer to do the field sketch, or even started from very beginning in our elementary school. Uh, we already draw, and drawing. I think for me, drawing is more interesting than to do math or calculation and so on. So it's easier without any. You don't need to really think about it. So I think it's easier. It's not so difficult to try. Yeah, just you need just to be eager to do that. So,
Okay. The most important thing are we dare to
yeah, I will put my
start
email
sketch.
on the chat box.
Yes. Okay. Any question? Because the time is almost over, let me read the conclusion about material from Mr. Hendy. Number one, sketch and illustration are essential for describing and understanding geomorphological aspects. And then sketch is not only for understand and describing geomorphological aspect. Sketch is also can you help your livelihood. Yeah. And for me, Mr. Hendy is just not researcher
Yeah,
or lecturer, but he is so a great sketcher. Okay. From your presentation, we can take some insight and more benefit from you. I hope your studies is smooth, healthy, you and family, and come back to Indonesia as soon as possible. Okay,
thank you very much. Thank you very much.
so
Yeah.
before we end the session, let me second our appreciation for our speaker, Mr. Hendy, for joining and deliver the new insight. Is the certification. Yeah, this is a certificate for Mr. Hendy for joining the ICGDM in Geography UMS as invite speaker for the title Reviving the Use of Sketch in Earth Science Studies.
Thank you very much, Lima. Thank you very much for Mr. Hamim as well for inviting me to this beautiful event. Thank you, everyone in ICGDM. Thank you very much.
Thank
Okay.
you.
Thank you. Mbak Anti, please help to photo session.
Okay, thank you very much to Mr. Ma and also Mr. Hendy Faturrahman, Master of Science, for the presentation. And the next is photo group session. Please to all participants to turn on the camera. Please turn on the camera for photo group session. Okay, let me help to take a picture in photo group session. Okay, 1, 2, 3. Okay. One, 2, 3. Okay, great. Thank you very much.
Thank you very much, Mbak Anti and everyone.
And the next session, we will see presentation from the third invited speaker, Mr. Muhammad Alfaristama, PhD. In this presentation, we will moderate it by Ms. Dewi Novitasari, Master of Science. And before that, I will introduce our moderator. Ms. Dewi Novitasari was graduated from Science Information Geography and Mapping in Gajah Mada University and continue her master program on Geography Specialist Geoinformation in Adam Mickiewicz University, Poland. Her research are mainly focused about remote sensing and geographic information system. Ms. Dewi now works as full lecturer at Faculty of Geography in University of Muhammadiyah, Surakarta. Now, please welcome Ms. Dewi. Ms. Dewi, time is yours.
Okay, thank you, Mbak Anti. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Alhamdulillahirrabbilalamin, wassalatu wassalamu ala asrofil anbiya'i wal mursalin, wa ala alihi wa sahbihi ajma'in, amma ba'du. Good morning and over good afternoon, ladies and gentlemen. First of all, let us thanks to Allah Subhanahu wa Ta'ala because of His blessing we are able to come here to join on this session conference. Yeah, my prayers and peace be always upon the Prophet Muhammad Sallallahu Alaihi Wasallam. Thank you very much for preparing yourself and still joining us on virtual conference. Respectable for all invited speaker, the Honorable Lecturer of Faculty Geography, Universitas Muhammadiyah Surakarta, and Honorable all participants of this virtual conference. Let me introduce myself. I'm Dewi Novitari. I'm lecturer in Faculty Geography, UMS, and now serve as moderator of this session today. I'm very happy to see you here and welcome all of you to join this seminar. Okay, ladies and gentlemen, before we start the presentation, I would like to read the sequence of the last conference session today. Now I will read our agenda of this session. Before we start, I have several housekeeping in this session. The presentation time for invited speaker, Dr. Muhammad Aufaristama, will have 20 minutes for presentation. Following next with discussion, question and answer session for around 10 minutes. Today's session is being recorded to be available in viewing post-conference in Zoom and also in YouTube. If you have any question for presenters, please let me know. Use the raise hand feature in this Zoom. You can also submit a question via the Zoom chat feature, for presenter to answer this question. For those who are not speaker, please turn off your microphone as well so we can focus on the material. If you have a technical problem or question, please reach me out directly via the chat function. So before we begin, I would like to read the curriculum vitae from Dr. Muhammad Aufaristama. Now he is an active researcher in Center for Disaster Resilience CDR, University of Twente, the Netherlands. He got postdoctoral research in cloud computing, in geological remote sensing, applied earth science, AIS, University of Twente, the Netherlands, and also he got postdoctoral in image processing at volcanology and natural hazard research group, Institute of Earth Science, University of Iceland. He got a PhD of Earth Science, School of Engineering and Natural Science, University of Iceland, Institute of Earth Science, Iceland, and he have a research interest in remote sensing, image processing in volcanology and geological science, natural hazard, fluid flow modeling, numerical analysis, geostatistics, machine or deep learning and cloud computing, environmental and exploration geoscience, subsurface and surface mapping. So, well, ladies and gentlemen, without any further ado, let's open our session today by saying bismillah together. Bismillahirrahmanirrahim. Okay, Pak Aufa.
Yeah, hello.
Good morning in
Good
Netherlands.
morning.
Okay,
Good morning,
so
Miss Debbie.
you have 20 minutes, for presentation. So the time is your Pak Aufa.
Thank you very much for Miss David for introducing me, and also thank you for University of Muhammadiyah Surakarta for letting me to make a presentations and then to share with you all, and then we can have a fruitful discussion later on. I'll share my screen. Okay. Good morning, everyone, and also all the participants. Today, I'm gonna talk about mostly the mapping things, and which is mostly focusing in landslides. So my title will be Towards Near Real-Time and Continuous Landslides Detections and Leveraging Dense Time Series Analysis. So in this case, I will explore what currently we do in our research group and whatsoever about the time series analysis via the satellite observations. So this is the themes that working in this platform. Me, myself, Harald van der Werf, Mark van der Mede, and Hakan Tanyas. So the background and the key points for this talk is we have 5 points here. The first is about the remote sensing time series, which is analysis of multiple images over time. If we already get the time series analysis, we can provide valuable insights into landscape change that indicating might be landslide or another land change, since the conventional method often miss the full range of the landslide dynamics because landslide is so dynamic. And we also have 30 plus years, so it's almost 40 years Landsat satellite observation available on cloud server. It can be Google Earth Engine, Sentinel Hub, or whatever cloud service that we have. And the data itself, it's continuously added into the server. So we can have a near real-time monitoring in the end. And this is one of the novel opportunities for landslide mapping. But this is not only landslide mapping in the end. Whatever mapping that we do, we can do it in the time series. Let's see. So we all agree that change happens, change with times. That, for example, I give myself as an example in 1992, this is me. And then the other one, 1996, change is continuously changed, 2013 and 2017. So basically, according to times, we are changed. And the background, it's also happened in the land surveys. Change in land surveys are marked by shift in the time series pattern. For example, I have an example here, the surface property. We can have a gradual change, like down and up in gradual change, or we have abrupt change. We have abrupt change with recover, or we can have a like sinusoidal pattern, or this is the pattern of like temperature summer and winter and summer and winter. So this is all the change that we know. So how to measure this change? Mostly in remote sensings or in the image processings. We know that when we measure the change, we always use change detections, like from 2014 and 2013, for example. And then we just use 2 points here. 2 points, and we see the change between those two. But this is not enough, because in meantime, we have something here that not really covered by only change in certain moment. And in this one is the big gap that we need to solve here. That's why we need to have adequate measurements. For example, if we have every point in the lines like this, in the line of time, so that's the adequate measurement, because if we only use 2 points in between, it's not enough. So as I mentioned before, we have a gradual change from the state 1 to state 2, which is vegetation growth. And we have also the state 1, state 2, which is the decrease in vegetation because of the long-term stress, sorry. And we have an abrupt change. This is most common in the natural hazards or in the anthropogenic change, for example, the building of a house or another else. State 1 to state 2, we have an abrupt change. So the concept, for example, I give you example, if we use the data from 1990 to 2010, if we plot single pixels like this and like this, so we have only 2 data points here. So if we have 3 clear observations, growing season 1990, 2000, and 2010, so each different 10 years. And if we have enough data, again, we add another observation from 84, 2010, with the clear growing season observations. And again, we add more data sets. Almost all the data set we put here, multiple clear growing seasons and off-season observation we put here. And if we had all of the data sets, this is the data we have in the single pixels. So what we can do is try to match these data with the pattern or try to model the behavior of these data sets. For example, we use the approach called continuous change detection and classifications. So the term continuous here refers to ability to produce the landslide map at any given time within the term of observation period. So for example, here we have two segments. The first segment here and the second segment here. So this is called temporal segmentation. As we know in geography or geoinformation, we already know image processing in OBI, object-based image segmentation. But in this case, we are using time segmentation. So this is really important because we can distinguish the different type of the land, for example, like in here, from the normal pattern to after that we have an abrupt change here. So how this concept applies to landslides, for example, in this case. So first, we propose to implement this in the field of landslide science to continuously map the landslide in space and time under the Google Earth Engine platform. And this platform will utilize all freely available Landsat observations spanning from 1990 to 2020, so 30 years, basically. So before going to that things, I'll show you the three-stage toward near real-time global landslides inventory. So the three-stage of landslide detections, mostly most of the research focusing in here. So mapping the landslide, where's the landslide? This aim mostly for the complete inventories and precise spatial delineation. As you can see, mostly for the mapping, they need a really precise delineation of the landslides. And most common, this technique using very high resolution satellite image or with the UAV to map all these things. And also in level 3, it's a manual delineations. This aim for validation and stored into inventories database. So what we are missing currently is the level 1, which is fundamentally important for rapid response. For example, if there's something happen, natural hazard or landslide occur in certain area, we need really fast response instead of the really accurate delineation of the landslide bodies. In this case, we need the level 1, which is we overview the time series and overall trend pattern on the pixel level. So we can get overview of area that impacted by landslide with medium or freely available satellite images. So the aim for this stage to detect where are the changed pixels and when was that happen. So these 2 points is really important. Instead of we delineate the body, but in here we show you the where and when that happened. So basically in the time series analysis in landslide, for example, if the landslide happened in the highly vegetated area, we can see there's a drop in NDVI, for example, or increase in brightness index or in the soil index here. So our aim is to detect these breaks and then to segmentize the time in here, segment 1 and segment 2, segment 1, segment 2, and etc. So another criteria that we use also we use the low break in NDVI and also slope that more than, for example, 10 degrees. This is varied. It's different between place. So this is really flexible and put this criteria. So let's see if we use this criteria. So imagine if we have single pixels like this. We have the signals of these single pixels. Basically, this is the 30 years data sets in the single pixels, because each pixel tells you a story. And then this temporal segmentation allow us to summarize this story itself. For example, in here, in this single pixel, we have 3 segments, which is first segment, and this is mostly maybe the vegetation growth, and then suddenly this drop. And we are interested in this drop. So this drop happened in 2016. So for example, we have the single pixels, we have time, and then we move from the single pixel to temporal, and from temporal, we move back to spatials. And in the end, we can map every single pixel of change based on the date of the change, exact date of the change. For example, this is happened in around 2015, and then this is in 2022, this is in 1990. And after that, we can classify this. For example, this is a landslide due to the landslide, and then this is the landslide that happened in around 2005, and then this is the landslide that happened in 2019, for example. And then in the end, we can have a dynamic of the land like this, for example. So when the certain lens change happen. So from here, we can interpret, oh, this is 2015 due to the earthquake in Nepal. This area is in Nepal. Earthquake in Nepal in 2015. That's why we have a big change. That's due to the landslide occurrence. So I'll show you the examples in the 5 different areas in Kashmir, Pakistan, in Porgera in Papua, in Hokkaido, Japan, Karnataka, India, and also Pasang Lamu, Nepal. First, if we adapted that algorithm to that 5 place, this is what we get from the Kashmir in Pakistan. We can see this is the blue. It's the landslide that happened in 2005 during the Kashmir earthquake. So that's why we have a big spike in this change during 2005. And then we have the stars here. These stars related to change too, but this is not related to landslide. After the careful inspections, we see this change due to the relocation of this city that affected by landslides. They built the new city in Balakot. So basically, they do all the deforestations during this period. And if we move also to Porgera, Papua, here's the distributions of the land change during 2020. And we have a big spike also in 2018. This is the second most largest landslides that happen in the earth. So this captured quite well in this algorithm. We can see these spikes happen because of the landslides. And also for the Hokkaido, Japan, it's similar because the transferability is quite well. So we don't need to change the parameters as long as we already define our criteria like in the beginning. So we can move in all over the areas, and then we can test whether this valid or not. So like in Iburi, Hokkaido, Japan, like here we have a spike in 2018 and 19 here due to the earthquake in Iburi. And also in Karnataka, India, we can see the dynamic of the areas itself. We have a change in 2018. This is because of the heavy rainfall during this period, and then it's caused landslides. And the last one, the Pasang Lamu, Nepal. We can see the dynamic is quite varied compared to other areas because this areas is prone to landslides. Landslides happen not only because of earthquake, but the activities of the glaciers also influence the results here. So we can see the dynamic of the land change during the period of 30 years here. So what we can do also, because we want to know when and where, we already know when is that certain event happens, but now in order to assess where's the area or the densities of the area, we can perform the area per slope unit comparison. For example, like this is our proposed method, and this is the reference inventories that we get from the field. We can compare between those two, and then we can have a linear regression in here in between. So we can see how well our method compare with the manual mapping. And also similar with the other area, we can perform that one. And also for the Porgera, Papua. But for the Kashmir and Hiburi, Hokkaido, the overall accuracy fall within the 77% and 83%, with the false positive around 13% and 5%. And we are still in process of gathering data on historical landslide, so we can match between the different landslides and then see what result that we get. Is this really landslide, or this change to the landslide, or other type of land use change? And talk about the false positives. That's always happen in mapping. We cannot ignore the false positives. But in here, for example, I give you in Papua, in Porgera, during 2011 and 2013, we have significant change that highlighted in this red box. This change was not caused by cloud or shadows, and it's not classified as landslide also. And this change contributes to around 20% of false positives. But what is this change basically? This is not landslide, and then there's no trace of landslide here. We can zoom in here, and then we can see this is like a river pattern, but this is not river. But after closely look here, so we notice there's word change related to road construction due to mining activity. So basically this is landslide, but this is not natural landslide. This is due to anthropogenic landslides, that when you open the mining site, for example. So this also detected by this algorithm. So with the natural change from the landslides, and also anthropogenic landslides also detected in this case. So this type of change commonly detected by the algorithm. So the conclusion and the future works. So we developed a robust method for the rapid multi-temporal landslide detection under the cloud computing platform. In this case, we use the Google Earth engine. And we achieved the spatial temporal mapping of landslide in 5 different regions with acceptable accuracy, considering we are still working with level 1 detection, which is using medium resolution image. And we are now working in integrate the method using Sentinel-2 and also harmonize both Landsat and Sentinel-2 to achieve the dense temporal resolution. And later on, we can have a also better understanding of the change. And thank you very much.
Okay, thank you so much, Pak yeah, for excellent presentation. So the participant, if you have any question for invited speaker, please raise your hand, or you can also put your question in the chat column. Don't forget to introduce yourself first, yeah. So we have a question from Mas Fikri Trisusilo. Hello, my name is Fikri and I'm from Geography. So my question is, what are the advantages of foundational concepts that are important to develop? What are the different challenges in the research process in each of this country? It is a different country. And for areas that don't have reference inventory along with landslide size and polygon information, how can we maximize our research?
Okay. Thank you very much for the question from Mr. Fikri. And yeah, but that's a really good question. So the challenge itself in here, of course, lies to the indices that we use. Basically, this is only limited for the landslide that happen in the highly vegetated area. For example, if we are working in the semi-arid region, which is the landslide happen already in the bare soils, and then bare soil as a proxy of the landslide, this method will not work because we are working in the NDVI. But if we want to use this method in those kinds of areas, we can change this index. Instead of NDVI, might be we can use bare soil index or brightness index in those areas instead of NDVI, so that we can adapt to certain area. And the second one, about the reference inventories, yeah, I agree, because nowadays there's limited, especially like in Indonesia, we are really limited landslide inventories and polygon informations. So how can we maximize our research? What we can do with this method is, of course, first, we need to test this method in the certain area. For example, in Indonesia, if we see the pattern, for example, like this, the pattern, the change in 2010, 2015, what we can do, we can go back to the date that this pattern happened. For example, there's a pattern of change in 2015. We need to find news article or data sets or image that cover during 2015 in those areas. And from that, we can try to compare our results to that, what happened in the image. And then after that, we can build our polygon in the end. We cannot assess the landslide size, but we can compare that's happened in 2015, because often landslides is missing in the mapping, because the landslide itself is not happen due to earthquake, but mostly happen also during the heavy rainfall, which is undocumented during that period. That's what we can do.
Okay, thank you very much, Alpha. Yeah. So this is another question. Let me introduce myself. I'm Iswidiantara. I think it's one of our students. Yeah. I have a question about GEE. What are the advantages of the method GEE besides being free and having time series? Thank you.
Yeah. Thank you, Mr. Iswidiantoro, for the question. So the advantage of using Google Earth Engine, basically, I would say it's free for now. I would not say it will be completely free until next 10 years or 20 years, because basically this is Google Earth Engine is a company, and the company need to make a profit. Maybe in the future we have a subscription. So this free advantage is also disadvantage in the end. But the advantage in terms of method, I would say we can do the time series analysis that you already mentioned, and also planetary scales. Like my examples, basically, we have the data sets there. The method itself we can develop by ourselves, but the data sets that we don't have at this moment. So that's why the importance of Google Engine, they store the database, and then we need to take advantage of the database into our results. In this case, time series is really the advantage of the Google Engine and the planetary scales. Because if you use the traditional method, for example, like in this example, you want to analyze 30 years of data sets in single pixels, you can do basically in your computer or traditional things, but imagine how many data sets you need to download. For Landsat, for example, every year, maybe we have 20 or 30 Landsat data, multiply by 30 years, so 900 Landsat data that you need to download and then process until it's done. But basically in the cloud computing platform, what you need only move your algorithm or your questions into the platform and let the platform work. So that's the advantage of using Earth Engine or the cloud computing platform in general.
Okay, thank you very much, Pak Alfa. So anyone for the participant still have a question for Pak Alfa? Or maybe the question from myself, yeah, Pak Alfa. I think your presentation is very nice and good. And now we have a cloud computing, and GAA is like a new generation for GIS or remote sensing data, yeah, and processing. And I just want to know, how do you ensure that remote sensing application are compliant with industry standard? For example, for Sentinel data, they have their own classification like that. And of course, it's a difference itself with Indonesian standard or maybe other country classification. And so how do you ensure that remote sensing application are compliant with industry standard?
Yeah, that's good questions. It's also tricky to answer. So basically again, in the if we talk about standard of mapping, each country or even each satellite department, they have their own standard. But what we need to do, if we already have cloud computing platform, in the future maybe we have only single cloud computing platform. To ensure that happen, we need to agree in for example, in geoscience community, to agree within, for example, to mapping landslide, we only need unit or slope unit as our standard. So now no one in the country use different style of unit, but instead of the slope unit, for example. So we need to agree and disagree in this case to have a standardized of the mapping. So for example, in the data sets also, the data sets that we use, for example, also need to comply the standard. For example, if we want to do the image processing, we need to use the level 2 data sets instead of level 1. It's already surface reflectance. And yeah, that's a lot of things to address in this term. I don't have a right answers at this moment.
Okay, so it's still challenging, yeah.
Yeah.
Okay, so there another question from the student. What specific challenge did you encounter in implementing the CDC algorithm in the field of landscape science, and how were these challenges addressed during the research process? From Hamam.
Yeah. Thank you very much, Ms. Hamam, for the questions. So like the previous questions, the challenge is always in the implementing the indices that we use here, because not all the area that we doing the mapping is the highly vegetated area, or not, or the area that's prone to landslides is highly vegetated area. That's why in this case, this drop or abrupt in NDVI will not work in the certain areas. To address that challenge, we need to find better indices that work to that area. For example, if we move NDVI to mostly brightness index, if we want to see, that soils that already gone and then change into fresh soil, maybe the brightness will be increased. So we expect there's a spike in the brightness, and then we can map or put this as a trigger of the landslides. Maybe that's one of this challenge. And the second one, the challenge, it's always the questions before about the landslide size and polygon information. So the previous question highlight if the area there's no reference of the polygon size or landslide information, it's really difficult to confirm whether this spike is related to landslide or this spike is related to what kind of change is that. So that's those two challenges we still in terms of the progressing of this challenge. Thank you.
Okay, thank you very much, Pak Alfa, for the great answer. So anyone still have a question? Or maybe because the limitless of our time, yeah, I would like to read the conclusion from Pak Alfa presentation. The first robust method for rapid multi-temporal landslide detection under the GAA platform across vast area, making use of freely available unlisted data set. And the second, spatial temporal mapping of landslide in 5 different regions with acceptable accuracy, considering on the alpha working and team with level 1 detection using medium resolution image. And it's still possible to integrate the method using Sentinel-2 with better spatial and temporal isolation, and also harmonize both Landsat and Sentinel-2 data to achieve dense temporal resolution for CDC in the future world. Okay, thank you very much, Pak Muhammad Alfaris Tama, as amazing presentation for invited speaker. So before we close this session today, we would like to give an appreciation for Dr. Muhammad Alfaris Tama in the form of certificate. Mbak Anti, can you help me to share this certificate maybe?
Okay. Wait for a while.
Okay. Thank you so much, Pak Alfa, for your nice and great presentation.
Thank you very much, Pak Dewi.
Yeah, hopefully we can have another collaboration in the future with Pak Alfa and team. And also thank you for all the participants for very active participation in this seminar. And before we close this session, we will take a photograph. Mbak Anti will help us to take a photo maybe.
Okay. Please to all participants to turn on the camera. Okay. We will take a picture. 1, 2, 1, 2, 3. Okay. Once again. 1, 2, 3. Okay, thank you very much.
Thank you.
Thank you very much. Thank you.
Thank you, Pak Alfa and our participants. After this session, we still have final session of each track paper, so still keep in touch. I'm Dewi Novitari as moderator. I also apologize for my mistake if in delivering my speech, if any. Wassalamualaikum warahmatullahi wabarakatuh. Give back to you, Mbak Anti.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you very much, Ms. Dewi, and also Mr. Muhammad Alfaristama, PhD, for the nice presentation. And okay, ladies and gentlemen, after this, we will continue to our paper presentation session. But first, I will explain to you all that the meeting will be divided for 4 rooms, and each room will have different theme. For the track 1 is physical, the track 2 is social, and the track 3 is technical, and the track 4 is disaster. For participant who will present your presentation, please join based on your paper track. And for all the participants, you have free option to choose which room you will join. And I will remind you all, after the paper presentation, we will have the last keynote speaker, and don't forget to join again at 17:30. So let's start and move to our paper presentation, and see you at 17:30 in the main room.
Halo. Mbak Anti? Mbak Anti? Hai Mbak
Oke,
Anti.
Pak.
Oke, let's begin.
Bismillahirrahmanirrahim. Alhamdulillah, alhamdulillah alamin. Wabihi nasta'in wa ala umuri dunya waddin. Wassalatu wassalamu ala asrofil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in amma ba'du. Thanks to Allah who has given us many mercies and blessings so we can continue this agenda. May prayers and peace be always upon the Prophet Muhammad sallallahu alaihi wasallam. Good afternoon, ladies and gentlemen. Welcome to the International Conference of Geography and Disaster Management, ICGDM 2023. Thank you very much to join again in our second day of ICGDM Virtual Conference 2023. The first, I would like to reintroduce myself. My name is Antia Sobiro. You can call me Auntie, your Master of Ceremony for today's conference. After doing paper presentation session, we will listen presentation from keynote speaker in second day of ICGDM 2023, Mr. Esagu Calvin MA from Kiambogo University, Uganda. And this presentation will be moderated by Mr. Afif Ari Wibowo, Master of Science. Before doing presentation, I will introduce our moderator. Mr. Afif Ari Wibowo was born in Kebumen, 24 March 1991. He was graduated from Environmental Geography and continued his master program on Master in Coastal and Watershed Management Planning, MPPDAS. His research are mainly focused about physical geography, disaster management, renewable energy. Now, Mr. Afif works as full lecturer at Faculty of Geography in University of Muhammadiyah Surakarta. And now, please welcome Mr. Afif. Mr. Afif, the time is yours.
Okay, thank you, Mbak Andi Amania, for your me. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Wabarakatuh.
Good evening, ladies and gentlemen, and good afternoon, our speaker, Mr. Esagu from Uganda, Honorable Chairman of Faculty of Geography, Mr. Sumedi, PhD, and dear all Geography Department lecturer, and honorable all participants of this seminar. Ladies and gentlemen, I'm Afif Aribowo, the moderator of this evening seminar in invited speaker session. I'm a regular at Faculty of Geography, Universitas Muhammadiyah Surakarta. I'm very pleased to see you here and welcome all of you in this seminar. Okay, today's seminar is about the fifth International Conference of Geography and Disaster Management. Okay, we will start again this seminar with last invited speaker. He is Mr. Esagu John Calvin, M.A. Emling from Kiambogo University, Kampala, Uganda. Okay, before Mr. Esagu will present his material, please give me several time for read the speaker background. Full name, Mr. Esagu John Calvin, M.A. Emling, you can call him Mr. Esagu. The place of residence of Mr. Esagu at Najera, Kampala, Uganda. The background education of Mr. Esagu are Bachelor of Art with Education in Geography or History at Kiambogo University, Kampala, Uganda, and Master of Geography at Kiambogo University, Kampala, Uganda. Also, Master of Environmental Science at University of Diponegoro, Semarang, Indonesia. The key expertise of Mr. Esagu, geographical information system and remote sensing,
disaster risk assessment using GIS, geospatial technique, and natural resources assessment, GIS-based. For the recent research area in 20 and 19, dam flood emergency preparedness, response, and recovery assessment for Kabunenda, Isinyoro District, Western Uganda, and 2023 about Karwal production and the Sinats tree vegetation dynamic in Kapele Pyong District, Eastern Uganda. And the work experience of Mr. Sagu in 2022, they'll present as an assistant regular at Department of Geography, Kembuku University, and from 2018 until 2022 as a teaching assistant at Department of Geography, Kembuku University. Well, Mr. Sagu will present about prediction of Kabuyanda Dam failure inundation and its impact on the communities of Isingiro district. Okay, Mr. Esagu, you have 20 minutes to present your material, and next we will move to question and answer session for 10 minutes. So participant, you can write your question to chat box before Mr. Esagu finish his presentation. So please welcome Mr. Esagu John Kelvin MAN to this conference. Now, Mr. Esagu, time is yours.
Yeah, okay. Thank you so much. I'm really very happy to be part of this international conference of geography and disaster management. I would like to share my slide then. Okay, thank you so much. Are you able to see my screen?
Yes, it's clear.
Okay, thank you. So that is those are my details, and my name is John Calvin, from Uganda. Sorry, I have no. Yes, basically disaster management and prediction of flooding, and flooding is really a very pertinent disaster all over the world. Here in Uganda, it's a big problem. Well, I don't know about Indonesia, but I believe global and worldwide, it's really a very big problem, and that is what I'm really interested in. And so I am going to make a brief presentation here. I'm going to move quite faster because there is no time. Yeah, are you able to hear me?
Yes, right.
Okay, thank you so much. So I am basically concentrating. I'm 26 years old and I have 2 masters now, and I have an interest in also proceeding to a PhD soon, maybe if I get a scholarship anywhere. And so my interest is basically in GIS and remote sensing, and seeing how to integrate remote sensing and GIS in helping to predict and managing environmental disasters. And I am really looking at being an expert in flooding, all types of flooding that usually have an impact on the environment. Okay, so this is my brief background, and I'm basically focusing on here in tropical Uganda as a country, that we have some areas here in Uganda which are basically dry, and other basically other sub-Saharan some areas in sub-Saharan Africa. And so here in Uganda, there are areas which are dry, meaning that agriculture is a very, very, very big problem. And yet 90% of the people here in Uganda depend on agriculture or crop production as a major source of life. And therefore, the government has come up with multiple programs that aim at constructing dams. And these dams are basically supposed to be used for agricultural purposes by providing water for irrigation, so that they are able to carry out agriculture even during the dry season. However, in some parts of Uganda, some dams have instead collapsed, leading to flooding. And this flooding has affected most of the communities in the country. And so it is recently in the GIS world, it's important to predict and to be able to forecast the possibility of flooding, basically resulting from dam breakage. And that is what my analysis basically focused on. And from this slide here, I have displayed a photograph here. Up here is that area where the government is planning to build the dam. And then this other section is the area that will be irrigated. So the dam is to be constructed on this uphill area where you have the red circle. And then on this yellow section here is the entire area that will be irrigated or that will be provided, where the water will be sourced for irrigation, such that they are able to carry out crop cultivation. However, according to my research, it's discovered that this area here is basically a mountainous area that also experiences erosion. And at the same time, there is flooding, of course, in the lower down section. But at the same time, this area is prone to earthquakes in most of the times. If you have been reading a lot, this area, Kabuyanda, is along the Rift Valley, the East African Rift Valley, especially the Western Arm. So most of the times it experiences earthquakes in the area. So there is a possibility that if the dam is constructed in this spot and there is an earthquake, and at the same time you have soil erosion that deposits sediments into the dam, there is a possibility that this dam can easily break. And therefore, all the water that was contained in this reservoir will lead into flooding in this downer area that has been irrigated. So my research investigation was basically carried out in Isingiro district. Isingiro district is located in Western Uganda, and Uganda is in East Africa. And Africa as a continent at large. So it focused on predicting the extent of flooding if the dam breaks. And secondly, to also assess the various human activities or the elements at risk that can easily be destroyed by the floods. And to determine also the damages and the losses that can be experienced in case the dam breaks. And lastly, to come up with a few strategies that can be put in place and to reduce the possible damages in the area. So as you see from this map, I used GIS and remote sensing to develop this map. I don't want to go into detail because there is no time, but up here, this section which is red in color, that is the area that is basically a floodplain, that area which is usually affected by floods. And then up here is where the dam will be constructed. So my prediction is that given all other factors, if this dam here breaks, what will be the losses downstream here? And so this is the section. This is the dam, the reservoir, where the water will be collected. This is the dam site. And this water, of course, will be passing through this section such that the people down here are able to obtain water for irrigation. And so this is my brief data collection. I may not go deep into it, but basically I used GIS and remote sensing together with various models like HEC-RAS and then also HEC-GeoRAS. HEC-GeoRAS is a plugin in ArcGIS Desktop 10.8, and HEC-RAS is a software or a model that is used for hydrological analysis. Yeah, and then other things here, I obtained data sets from different areas, for example, population, schools, water, police posts, and also other data sets. So I used this data to perform flood analysis that can give us a few results on how the flood would be. And this is also part of the methodology, the DEM from USGS, then converted to contours. And then from the contours here, the tin displays the relief of the area. So up here with this blue section is the reservoir, the dam reservoir where the water is. And then down here, I developed river geometry of the entire area. So this place is mountainous, but this is the area where agriculture or where people are settled, where you have various land use activities within this section here. Yeah, so this is a simple methodology that I developed to come up with this. And so using GIS and remote sensing, I did flood analysis. And the first one here, the first map shows that is flooding, what has been taking place in the area. That is the extent of flooding. So the area which is usually flooded is about 6.5 kilometers squared only. But according to my model prediction, if the dam is constructed in this area, and then it can reduce flooding in this area by 9.5. So it's only 4 kilometers square that can be flooded. However, according to my other analysis from this point here, if the dam breaks or if the dam fails, then 17.4 kilometers squared will be flooded. So it means this is too much land that will be flooded in case the dam here breaks. And as I've said that earthquakes, soil erosion, and then negligence and too much rainfall can result into accumulation of water in the reservoir and therefore leading to flooding. So it would flood 17.4 kilometers squared if you have that dam break. Okay, and so I also used the model to calculate how much the velocity of the water in the area if this dam here breaks. So you can see here, the water would move at approximately 11.9 meters in a second. So that is really too much speed. And then for depth, this is a depth map, and areas which are high, moderate, and low, but the highest is 8.4 meters deep. Yeah, so the lowest areas within the floodplain would be about 8.4 meters deep if this dam here breaks. So these are the predictions from the model that display the velocity upon which the water is moving from the dam up to the low-lying area, and then also the different depth or the areas that will be flooded by this dam. Okay, so this slide here basically shows the elements at risk. This is, I divided this flooding into high flood, moderate flood, and low flood, as you can see from this map. So if the dam breaks, the flooding disaster would destroy or would lead to death of about 5,000 people in the floodplain. And then also, if the dam breaks, about 339 hectares of crops will be destroyed by that flood. And for the case of buildings, about 1,439 buildings will be destroyed. And then roads in kilometers, 47.11 kilometers of the roads will be destroyed by the flood. So when you look at this point for this map, we have here schools. These are schools that will be destroyed by that flood. About 8 schools, 8 water sources, 1 police post, and then a health center. The map on the left-hand side here is basically the roads that will be destroyed by the dam flood in case there is breakage. So these are basically elements that are exposed to the dam flood disaster. These are areas, croplands, houses, and then also a bit of crop gardens that will be destroyed by the flood. This other photo basically shows the area. This is the area that will be destroyed by the flood, and the dam will be up here. And I've already talked about these elements at risk. So you can see the buildings in the area that will be destroyed in case the dam breaks. And then the roads, the land use activities, the croplands, and of course, there are many people who are staying within the floodplain that I've showed there. And so I also used the model to try to estimate the damages to this dam flood hazard. Okay, so about 136 buildings will be completely destroyed. You see, so all this section shows what will be completely destroyed, and then that which will be moderately destroyed, and then here will be slight or no damage at all. Yeah, so this is the analysis of the estimated damages and losses in case the dam breaks. And then I also used the model to calculate the losses in terms of shillings. How much money can be needed to replace what has been destroyed. So in summary, the government of Uganda would require about 4.1 billion Uganda shillings to replace what the flood will destroy. And in Indonesian currency, about 16 billion. This is for Indonesian currency, that I try to estimate. So about 16 billion Indonesian rupiah will be needed for the government to recover from that flooding. So these are the damages and losses that can be experienced from the dam flood disaster. And so I came up with a few mitigation measures on how to solve, and using in vivo analysis tool. These are the different strategies. I may not explain all of them. As you see, there is evacuation of the people who are staying in the flood disaster area. Then also to ensure that the dam is constructed well, that there is quality dam construction. At the same time, there is need to have flood resilient infrastructure, especially outside here. The people who stay here should be able to construct structures that can easily resist flooding, as well as other strategies like first aid, floodplain zoning. And so because evacuation is very important, I also used GIS to come up with what you call evacuation zones. Those are the areas which are somehow safe. The red polygon here is a very, very disastrous area which people should not touch whenever they are constructing roads or doing any land use activities. So these are evacuation areas that can be the government can use to evacuate people. And then these are the flood, the what you call the evacuation routes. So I also used GIS to estimate or to come up with a few routes, areas that people can use to escape from the flood to the safest areas. And that is what this usually that is what is showed in this map. So this software is very powerful in helping in predicting the flooding in the area and how the people can be helped, but specifically flooding from a dam, because you see here the dam is located uphill, and then these are the places to be irrigated or areas of irrigation. Okay, and these are a few recommendations that I've come up to give to the government of Uganda, that the engineers who are constructing that dam should be able to look at the flow mechanisms of the river. This is the main river that supplies water to the dam. And so the engineers here should be able to look at that. And so the government should also empower people to restrict land use. Like a settlement should be very aware from the high flood zone. And also public awareness is very important on dam risks by promoting access to flooding information. So the people in the area should be informed. Information should be given to them on the possibility of a dam break so that they are able to plan during settlement and also crop cultivation. And then also to have committees. Yeah, these are community response and rescue committees can be put in place such that there is before, during, and after flooding, and that early warning systems can be put in place to help secure the people from the possible dam flood disaster. Okay, so thank you so much. Because of the time factor, I would really beg to end here, and for this presentation on predicting the possibility of flooding from a dam, and also to help manage disasters, global disasters that can arise from the flooding. Thank you so much.
Okay, thank you so much, Mr. Isagu, for your interesting presentation and interesting information for us. Okay, well, ladies and gentlemen, now come to the question and answer session. Please raise hand or write your question in chat box. Okay, and the first question from Bu Vidya in the chat box. I will read to you. What are the mitigation measures currently done by the government and local people?
Okay. Thank you so much, Vidya, for your question. I am going to respond to that question. Okay. So I'm going to use this to respond to your question. Okay. So the mitigation measures. Okay. This is a prediction. Right now, as I speak, the dam is being constructed. The construction works are carried out right now in the area. And the mitigation measures that are put by the government are, for example, you can see here, there is a disaster relief program. So there are 3 strategies that the government is trying to implement in the area. The first one is before the dam or before flooding. And then the second ones are those that can be implemented during the flood or when the flood takes place. This is a prediction. I don't want to be a prophet of doom. The prediction so that, okay, most likely if nothing is done, then the dam can break. So things like resettlement by evacuating people who are staying very close to that river where you can have flooding, or to the area of a high flood zone, are currently being evacuated, and the government is is preparing a way of providing funds on how they can construct in other areas, and then also trying to demarcate the area that this area can only be used for crop cultivation. And then there are also areas that the government is hoping that can basically be used for tree planting. And then there are areas that can, of course, be used for specifically crop cultivation. And so the government is also trying to of course, there is establishment of a meteorological station where we can monitor the rainfall totals in the area. And then also, this information is to be availed to the people, the engineers who are going to construct the dam, so that they can use very strong material that can easily help to hold water and to also resist on earthquakes that can result into breakage of this dam. So the local people really don't have a lot to do. It is the government and then the disaster committees together with the ministries like Ministry of Water and Environment, National Forest Authority, and then also Uganda National Environment Management Authority. So this is basically a prediction. And so the strategies which are put in place right now are meant to help people to prepare for a possibility of flooding in case you are having that dam break. Yeah, thank you. I hope I have really answered you. Mas, back to you.
Okay, thank you, Mr. Sagu, for your explanation. Miss Ibu Vidya, I think it's clear, right? Okay, maybe someone else for the question for Mr. Sagu, you can raise hand or directly speak on this forum. Okay, the next question from Mr. Hamim. I will read for you, Mr. Sagu. What kind of early warning system for flooding that has been applied in the study area?
Okay, so what kind of early warning system has been applied in the area? Okay, so currently the government is planning to buy, because the early warning system for flooding of a dam are really quite very expensive, but the government is trying to come up with to buy machines that water level detectors. So these machines are planted in the area such that if the water levels increase, then there can be an alarm, and this alarm can, of course, spark the entire community such that they are able to vacate the area before the water levels increase. And then local radio stations, of course, within the Kabuyanda area that can be able to announce maybe before flooding takes place. And then employment of local disaster fighting youth who can be able to move around with vehicles to alert the local communities in case there is also a possible dam break. So it is basically machines that detect the water levels in the area, then to local radio stations and maybe TV channels that are fast, because the beauty with it is that the dam is quite very far from the communities. And if the dam breaks, it can take about maybe 1 hour, okay, about 30 minutes to 1 hour for this water to reach the local community. So if there are these announcements in the area, and then the machines to detect and also to be able to disseminate information to the local communities, basically before the dam breaks, they are really quite going to play a very big role. But because it is a prediction, we are trying to predict what can happen in the future. Yeah, these are just the things that are being suggested, and the government is really right now through the World Bank support is really trying to implement these early warning systems in the area.
Okay, thank you, Mr. Isagu, from your explanation again. All right, we have maybe 3 minutes again. Maybe one more question for participant. Okay, maybe enough, Mr. Sagu, for from all participants. And thank you, Mr. Sagu. So, ladies and gentlemen, we finally come to the end of this session of this seminar. Before I close this seminar, I would like to take a conclusion from what the speaker has presented. Okay, the ever-increasing population, so water supply have a great impact that major respond. We have to with the dam. Our dam have been constructed. Unfortunately, there have been several reports of the dam failure claiming. So the prediction of like the potential dam flood hazard is paramount in reducing the possible damage. So from the result of Mr. Isagu, the flood velocity is characterized by being high up to 11 near 12 meter per second, and the depth of the flood water to the potential dam failure up to X.4 meter. So the element ethics of this disaster, such as the population, cropland, building, and road. So the engineer and the management commit should be integrate flow control mechanism, and land use restriction should be implemented in line with the flood zone. Okay, well, as thank you for your participate as a invited speaker in this conference. Now we will share you virtual certificate to Mr. Sagu.
Okay, thank you. Thank you so much, Mas Afi. I'm really so happy. Thank you so much for giving me an opportunity to participate in this conference. Because I love Indonesians so much. They very humble and good people, and I graduated just a month ago from Undip University. That's where I did my second master's, and I'm really so happy to be part of this 5th international conference, and therefore look forward to attend other conferences in the future. And thank you. Your university is quite known here because there are quite many people who get scholarships there. And we are really very grateful that you're promoting knowledge worldwide and also other countries. Thank you so very much.
Okay, thank you very much too for Mr. Sagu, and this is your certificate. This certificate is present to Mr. Sagu Galvin MA from Kiambogo University, Uganda. as a invited speaker in the fifth International Conference of Geography and Disaster Management, Surakarta, 5 December 2023. Okay, thank you, Mr. Mr. Esagu.
Thank you so much too.
Okay, I'd like to thank you, the speaker, for the informative and interesting presentation, and all the participant for the very active participant. Finally, give the applause for the speaker and for you all. Thank you, Mr. Esagu. Okay, I close this session. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you.
Okay, no, Mbak Andi, time is yours.
Okay, thank you very much to Mr. Afif and also Mr. Esagu Calvin for the great presentation. And the next is photo group session. Please to all participants to turn on the camera. Okay, please turn on the camera for photo group session. Okay, 1, 2, 3. Okay, once again, 1, 2, 3. Okay, thank you very much.
Thank you.
Thank you,
Before we
Mbak Andi.
close,
Thank you, Mbak Andi.
okay. Before we close this agenda, I would like to take a moment to thank all of our distinguished speakers for their valuable insights and expertise that they have shared with us today. I would like to thank to all of participants also, the lecturer, student of college for the valuable contribution and for making this second day agenda successfully. Ladies and gentlemen, we have come to the end of this enlightening and informative second day of International Conference of Geography and Disaster Management 2023. I hope you all have enjoyed and benefited from all of the presentations and discussion of our distinguished speaker and the guests. Antia Mania, your master of ceremony today. I do apologize if there were many troubles. I wish you all the best in your future endeavors and hope to see you again in the next day. Thank you and have a great day. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Okay.
wabarakatuh.
See you. Thank you, Mr. Esagu. Thank you all.
Thank you, Mr.
Thank you very
Esagu.
much. Thank you, Mr. Esagu.
See you
Thank you, Mr.
again.
Afif.
Thank you. Thank you.
Ya, betul sekali Mbak Elisa. Nanti ini dilanjut di hari ketiga ya.